Hello everyone, welcome back to another episode of Days of DevOps. And we are currently in the container orchestration phase of our journey. Yesterday we started container orchestration. We got to see what it is. We did like a backstory. We brought out the two main words, container and then orchestration. And then we tried to explain how it all comes together. We looked at Docker, and we looked at the limitations that Docker had, and then we looked at or we looked at how container orchestration, you know, has come to solve those limitations. We also looked at the different container orchestration tools or platform, depending on how you may want to call it. So, just like we did in other places, we look at we list several tools, and then we focus on one or two of those tools. So our main focus in this phase will be Kubernetes. So we're focusing on Kubernetes. Like I mentioned in the previous video, there are different container orchestration tools, Docker Swarm, Mesos, Kubernetes, OpenShift. So and I said we're going to look at Kubernetes because it is the most popular one and it is the most adopted. Then I also mentioned that there might be maybe just one video on OpenShift. Yes, OpenShift is like Kubernetes. Then there's some add-ons, there's some layers on OpenShift. So if time permits, we'll look at OpenShift, maybe just one video for it, just do an overview of what is, but mostly we are going to focus on Kubernetes in this stage. And then we also look at GitOps, that's the CD part of our CI/CD. So once we're done with this part, then we'll look at CD and then we'll see how to join everything together and we'll see how far we can go with that. So today, what I'm going to do is we're going to explain Kubernetes architecture. So if you're a DevOps engineer, one thing you need to understand well is the architecture of things. If you don't understand the architecture of things, you wouldn't know where to go when something isn't working. When something breaks, you wouldn't know where to actually check. So that's why it's very, very important to understand how things work under the hood, the architecture, and how things connect. Same thing we did in our container phase where we took the time to understand the architecture of Docker. We also understood the life cycle of Docker. We're going to also look at the architecture of Kubernetes, and I would try as much as possible to see if I can do justification to this particular video. Hopefully, when I'm done with explaining the architecture, you will have no problems understanding how Kubernetes works. So, one of the reasons why Kubernetes um, is adopted or called it's okay. One of the reasons why Kubernetes is suited or suitable for enterprises because unlike Docker, where you install the Docker engine your on a single host machine, Kubernetes works in a cluster. So a group of machines come together, a group of servers come together to actually carry the Kubernetes workload, and that's what makes it really sophisticated. The good thing about it is it's sophisticated and funny enough, what makes Kubernetes actually a bit complex is because it's still in a server, which makes it also, you know, sophisticated and complex. So we have, let me do this. And the way the cluster works is just like every cluster, there is a master node and there is a worker node. So that's the first thing that I would like to establish in a cluster. There is a master node and a worker node. Yes, that is how it works. As a master, you can have one master node and several worker nodes. You can have three master nodes and several worker nodes, depending on how you want to set up your environment. But in on a high level, it's master node and worker nodes. And both master node and worker node they do different things. Yes, different things. Much of the workload is actually done on the worker node. The master node is there as a controller. It's like the brain that handles everything, but the work itself is done on the worker node. Let me just put master node for fan management. Yeah, let me just use that. And then worker node. This is what actually runs workloads. So if you're being asked the difference, master node basically just it's what manages, it's what oversees, it's what makes decisions when it comes to how the cluster is going to work, right? But the worker node just receives instruction from the master node and then runs whatever instruction that has been given to it. So I'm going to paint a picture here. Now, master node has components and worker node has components. So I'm going to list the components of the worker node. I'm going to list the components of the master node, and I will try to paint a picture on why I do that. Most videos you will see on Kubernetes architecture, most people will try to um, start with the master node and then list the whole components of master node before going to the worker node. In my case, I think I'm going to do the reverse. I'll try to start with the worker node and then link everything up with the master node, right? But now, before we even start talking about the components, let's go back to where all of this started from. There will be no need for orchestration, container orchestration, if containerization was not in place, right? So whatever we do, we still have to, one way or the other, refer to containerization, which in this case, I mean Docker, right? So I'm going to try to see how, I'm going to be mentioning or referencing Docker and then see how Kubernetes makes it much better. So in Docker, right, we have um, we have the Docker engine. From the architecture, we have the Docker engine, which serves like as the management of the containers. It pulls the image and it manages the life cycle and all of that. Then we have something called the container container runtime. This is actually the component that starts your container, that stops your containers. Basically, it is responsible for what stops your containers, right? So now these two are actually important, and then we'll see how they relate to Kubernetes. In the worker node, right? Since most of the workload is done in the worker node, one of the components in the worker node, though for some reason it's usually not really mentioned as a as a how do I put it now? It's not really mentioned as a prominent part of the worker node, but I would like to put it in the worker node, and I will tell you why. So the first thing I want to add to the worker node is the container runtime. And then there are different container runtimes. There is container D, there is cryo, there's whichever one you want to do, you use. So we can use let's say we use container D, right? We can use container D, but this is like container runtime. That's what the concept is container runtime. Container D is just one of the container runtime tools, right? So we have container D. That's the first entry that we want to put in the worker node, and this is what helps you know containers run basically. It's the same function it does in Docker, it's the same function it does in Kubernetes, basically running the containers. It starts the containers, it stops the containers, that is the work. So containers cannot, you know, start and stop if there's no container runtime in the whole architecture. So I'm not going to ignore container runtime. I'm going to put it as part of the um the worker node architecture. So now in Docker, the containers are run as okay, let me see. Images are run as containers, right? It is containers that we actually interact with when it comes to Docker. We go into one container and all of that. In Kubernetes, it's quite different. What container is to Docker is what pod is to Kubernetes. So in Kubernetes, things that run as pod, right? I'm not going to just you might not, I'm not going to explain what pod is right now. Maybe in the next video or subsequent times, we'll definitely we'll look at pods and all of that. So now, what we run in Kubernetes is pod. It is that pod that contains the containers that you know you actually now run, right? So what we have is pod. What actually what Okay, now we have the pod. We've talked about pod. Pod contains containers. Container D is responsible for those container running, but we need something to actually manage it, something to actually ensure that everything is working in place. And if something is wrong, report it to the master node for things to be done. Now, what oversees all of that? That's what we call the kubelet. The kubelet. The kubelet is something like an agent that is installed on each worker node to ensure that the each pod is actually running fine. Like there are no issues with the pod, and if there are any issues, it will report it to the master node. So that's basically, in a nutshell, that's basically the function of a kubelet. It is a kubelet that watches the nodes, that watches the clusters, that watches and ensures that each pod that is deployed on each worker node is actually working fine and making sure that okay they are being managed well. It is a kubelet that gives instruction to the container runtime to actually start or stop a pod. So that is like it is like the management agent in the worker node. It is the management agent in the worker node, and it is the only thing, or it is the only agent that talks to the master node. Whatever communication the master node has with the worker node is transmitted or is done through the kubelet. So without the kubelet installed in a worker node, there can be communication between the master node and the worker node. So let's just say kubelet is like the manager in the worker node settings, right? So now kubelet has given instructions to create pods. Pods have been created. The pods have containers and all of that. Now in Docker, each container that you create has an IP address. An IP address is meant for networking, right? It is meant for you to be able to access that container either from, externally or within your host, right? Now, it is the same thing with Kubernetes. Every container has an IP address, right? Every container has an IP address. Now, how do these containers? Now, when you want to create a pod, you create different pods, right? You can have like 5 pods, 6 pods, 7 pods in a node, and then how do they see each other? How do they communicate with each other? Right? Who gives them the instruction? Who tells them, okay, this is how you can reach this particular container, this is how you can reach this particular service. What gives us that instruction? In Docker, it is the Docker networking. In Kubernetes, it is the Kube-proxy. It is the Kube-proxy. So the Kube-proxy it basically ensures that all the necessary rules, everything that has been defined, policies and all of that, it's everything is implemented in terms of communication within containers running in the cluster. So that's basically what the Kube-proxy does. So we started with container D, which is the container runtime, and which actually starts and stops the container. We've also mentioned the kubelet, which is like the manager in the worker node that oversees and ensures that containers deployed in a pod or in a node are working fine. And if there's any problem, it is one that reports it to the master node for actions to be carried out. And we've also established that the kube proxy is what facilitates communication between pods and clusters in a node or across nodes. Right. So on a high level, these are the three components of the worker nodes: the kubelet, the Kube-proxy, the container runtime. In some videos, you might see two, which is the Kubelet and the Kube-proxy. But I feel personally it is important to include the container runtime because it also plays a crucial role in the whole setup and the whole, setting up of things. Now, I mentioned that the kubelet looks or watches for any issues with the pods and containers, and it reports it to the master node. Now, how does the kubelet do that? Through what channel, through what means can the kubelet communicate with the master node? And that is the first component of the master node, which maybe might be the most important part of the master node, and that is the Kube API server. Kube API server. If we have a knowledge of programming, we know that when it comes to APIs, we know what API means. API literally facilitates communication between two components, right? So the Kube API server is the entry point to the master node. It is like the gateway. That's the only way you can communicate to the master node, right? It is what facilitates communication between the master node and the worker node, right? So that is what the Kube API server does. So however you choose to interact, and again, I'm not just saying just the kubelet. I mean, even we as users, if we want to interact with the Kubernetes cluster, we do that through the Kube API server. That is the only way that we can actually communicate or that we can actually reach anything in the cluster. So this is like the most important part of, or one, yeah, let me say the most important part of the whole architecture. Now, the next thing, how does your cluster remember the state of a particular pod or a particular node? When it comes to scaling. Now, for example, now you deploy a pod that has one container or two containers, right? And then you want to scale that container. So how does the cluster remember that, okay, what we have is one pod. We want to scale to two pods, or let's say you want to bring it down and you say, okay, what we have currently is two pods. Now I want to scale back to one pod. How does your cluster know, okay, this is how many pods are running? Okay, this is the status of this pod. Okay, this is the IP address of this pod. Okay, you know, information about your cluster. How does your cluster retain it? That is where the HCD, that is where the HCD comes into play. This is like the database. I don't want to call it the brain. The brain is like the Kube API server. The HCD is like the database of your container. It stores every single information. If you let's say you want to get your number of ports now, you do kubectl get ports. You're talking to the API server, right? But now, where does the API server go to get the information? The API server will in turn talk to the HCD and say, okay, this person is trying to get number of ports that are in this namespace. Okay, I know I've used a lot of terms that you might not be familiar with if you're hearing this for the first time, but just chill. I'm going to explain all these terms as time goes on. Let's just focus on understanding the architecture. So now the QPP server reaches to the HCD and says, okay, this person needs so information, and then the HCD provides the information. So whenever you prompt your terminal and do kubectl get whatever, that output that you see is coming from the HCD. It is one of the most protected parts of your cluster. If anything happens to your HCD, your cluster is as good as gone, right? For your Kube API server, if anything happens to your Kube API server, the implication is that you will not be able to reach your cluster. That's the implication. But for your LCD, if anything should happen to it, regardless of whether you're able to reach the API server or not, your cluster is as good as gone because your cluster is basically it doesn't have any memory of anything again. no memories of the pods running, memories of the containers running, and all of that. So that is why most times in a in a highly available settings, right, the HCD is one of the most protected parts of the cluster. Just like in every system, database is something that you shouldn't take lightly. So same thing with the HCD. So now let's move. We've talked about the Kube API server and what it does. We've talked about the HCD and what it does. Now, when you want to um, create a pod, right, you don't talk to the kubelet. You can't talk to the kubelet. Like I said, the gateway to your cluster is the Kube API server, right? So when you want to create a pod and you send instructions to the pod, to your the cluster that okay, I want to so let's say I want two two containers of an engine two containers of Nginx, right? Yeah, so want two replicas of Nginx, and then we send that instruction to the Kube API server, and then the Kube API server says, okay, fine, everything checks out. Now there's a part of the cluster where you need to decide which node or which server. These things are actually servers, but in Kubernetes we call them nodes. Okay, worker nodes. Now, which node will I create this pod? That decision, the decision of which node, because you can't just randomly be creating pods in whatever nodes that you just feel like. You just say, okay, create this pod in this node, create this pod in this node, create this pod. No, there is actually a mechanism. There is a decision to be made in the core Kubernetes architecture. There are always decisions to be made, and that is why there is a master node, because master node does all the decision making and it just sends instruction to the kubelet. So despite the fact that kubelet is the one managing things in the worker node, kubelet cannot function without getting instructions from the master node. So now there needs to be a decision on which node should this pod run on. And that decision is not made by the Kube API server. No, that is Kube API server is just an entry point. Decision is not made by the HCD. HCD is just a database. The decision is made by the Kube Scheduler. Kube Scheduler, or you can say Scheduler. Okay, so decision is made by the scheduler. It is the scheduler that determines which node should a pod run on. There will be a list of instructions. There will be a list of criteria. Yes, criteria, that's the word. There will be a list of criteria that need to have been met for a pod to actually be placed in a particular node, because obviously every pod cannot have the same requirements. Every pod cannot have the same requirement. The requirement for an Nginx pod might not be the same requirements for a Jenkins pod, right? So it will not have the same requirements. So the Kube scheduler has to look at, okay, these are the criteria that needs to be met for this pod to be placed in this particular node. If it doesn't meet that criteria, it moves to the next node until it finds a suitable node that meets the criteria. And then once that is done, then the kubelet can now go ahead and then instruct the container D or the container runtime to create the pod on that particular node. So the kube scheduler is basically the one that decides which node should a pod be placed on. Basically, the pod is the one that contains the containers, right? So when I say pod, underneath it, I'm talking about containers, like you get. So now we could actually stop here and say, okay, what else do we need? This is basically like we've done almost, everything. No, not so fast. Imagine if, okay, now we're looking at self-healing here. We're looking at self-healing. Now, self-healing basically means maybe a pod goes down and then it recreates itself. The ability for Kubernetes to actually recreate that pod is one of the areas of self-healing. Now, Self-healing are in two ways. It is not just only the pod that needs to be monitored. The nodes also need to be monitored. The worker nodes also need to be monitored. Now, when a pod goes down, the kubelet reports it. There is a particular tool or there's a particular component of the management node or the master node that handles pod related issues. It handles pod related issues. And this particular component is called the controller manager. Controller manager. So the controller manager is what is responsible for controlling, to ensure that okay, the nodes are fine, the number of pod or number of containers that have been defined in a particular node is working fine. So it's the one that actually checks from time to time, you know, to ensure that everything is working fine. So that if there's an issue, actions can actually be, taken into. Now there are different controller managers. There are different controller managers. Now there is one that is called the node controller, and we also have the application replication controller. On a high level, these are like the two most important. There are several controllers. There's the cloud controller manager, you understand? But on a high level, so as not to overload us, let's just stick with these two, right? So we have the node controller and then the replication controller. So now what the controller does is that when you add a new node to the cluster, let's say for example now you have now we have two servers as a worker node. We want to add another server, into the cluster. The node controller is one that is responsible for, onboarding the nodes to the cluster. It builds up everything that needs to be done to make sure that that node is actually ready to receive ports or to receive requests. It's the node controller manager that does everything that refers to or that pertains to node. It watches over the node, make sure that the node is doing fine. If there's any issues with the node, it reports it. Basically, that is what the node controller is made for. It watches the node and ensures that the nodes are always and always in a good state. Now, the replication controller does similar thing the node controller does, but in this situation, instead of watching the node, it watches the containers. It watches the containers that are in the pod to ensure that they always, let's say for example, now you define that you want 3 Nginx containers. The replication container will always watch to ensure that that 3 Nginx containers that you define is what is always there. If there's any issues, if one container goes down, it is replication container that is responsible for informing the cluster that okay, this container has gone down, and then they do all they need to do, talk to the kubelet talks to the container runtime, and then new port is will come up in a matter of milliseconds. So the node controller watches the node and ensures that the nodes are in perfect shape. They confirm they do readiness check, they do liveliness check. They make sure that they're always checking the nodes to ensure that they are in perfect condition. Maybe I think every 5 minutes or thereabouts. So they check the node to ensure that everything is fine with the node. And then the replication container is controller is what checks the containers to ensure that the exact number of containers that have been defined in a pod or in a particular node is what is exactly there. So this is one of the ways that self-healing actually happens in the cluster. So now, I don't know, I've said a lot of things and I believe we've been able to pick one or two things. I've tried to simplify the architecture as much or as, when I say as much as possible, yes, as much as I can. So in the worker node, we have the kubelet, we have the Kube-proxy, we have the container D. To recap on it, container D is what actually starts and stops the container. Same thing that it does in Docker. right, which is the container runtime. The kubelet is the manager in the worker node. It is the one that oversees any issues in the worker node. If there's any issue, it reports it to the master node, and then actions can be taken on the master node. And then Kube-proxy is the one responsible for communication between containers in a node or containers within a cluster, as the case may be. Moving on to the master node part, we have the Kube API Server, which is the entry point to the entire cluster. That is the way in which you can actually gain access to the container, right? And every instruction that you send to your cluster goes through the Kube API server. And we said the HCD is the database the of the cluster, right? It's in the master node. It is what every information that you see in Kubernetes, whatever command you run in Kubernetes and you get an information from it, that information you are seeing is coming from the HCD. So it is stored in the HCD. If anything should happen to the HCD, your cluster is as good as gone. The scheduler is the one that decides which node should a pod be placed on. Through, it has its own criteria, you understand. So that is what the scheduler does. It decides which node a pod should be placed on. The controller manager is the one that watches the nodes and the pod to ensure that they are always in good health, right? So everything, all of these things, you know, it comprises or it brings about the entire architecture of Kubernetes. So as time goes on, by the time we get to by the time we start working on the terminal, we would see all of these things. Basically, all these things actually they can be set up as a standalone. You can have like a single server standing as an API server, a single server standing as an HCG and all of that. But we're not going to go through all of that. That is really, really complex to set up, right? But we'll see how we can set things up in a much more simpler way. So in the next video, we'll probably be setting up our Kubernetes cluster, or if we don't do that in the next video, we'll do that in the video after. But I know that soon enough we'll start getting our hands dirty. And I know I've mentioned concepts like pod and namespace and all of that. I've mentioned services, I've mentioned replicas and all of that. So we will also be looking at all of those concepts. So this particular video is just to explain the Kubernetes architecture. And I really hope that after everything I've said, you've been able to understand things on a theoretical level, right? On a high level. When we start doing things practically, you get more understanding of how things work. So if you've liked the video, please if you've enjoyed the video, please do also like it. You can share it to anyone that is struggling to understand the Kubernetes architecture and how things work. And also, if you're yet to follow my channel up to now, please do so. Follow the channel, and most importantly, turn on your notification bell so that whenever I post the next video, you receive it, you watch it, and then you can add to the knowledge that you already have. So that said, I'll see you on the next video. Enjoy the rest of your day. Cheers.